So in this homework assignment, we're really focusing on applications of quadratics, and it really boils down to these two formulas: the vertex equation when something's asked about a maximum, or if you try to solve something like setting something equal to 0 or 10, you use the quadratic equation. So what I would start off by doing is realizing that the first part, we're talking about a trajectory equation, which will be given to you. First part is the height, meaning the height at any given time. The negative 4.9 has to do with gravity on Earth. If you were on the moon or somewhere else, this would change. The v is the velocity. So in this case, we are looking at the velocity v right here. And then the s is the start height. And the start height is going to be started from 2 meters. So I would then open up a Desmos or a calculator, and I would type in the original problem right here, okay? You can see a graph of it, which is great. If you want to check it, you can check the maximum by doing that. I do want you to know how to find the maximum by doing minus b over 2a. As you can see, you do get the same value, right? 1.2, this one gives you to 3 decimal places. Now, that will give you the time. And that's one of the things we need to talk about is what does it give you? So we did the formula, but what does it actually do for you? Here, this will give you the time. So when it says when, right, when it says when does this happen, you're looking for the time. But the very next question, when it says what is the maximum height, the key is what is the height? And so this part is the height. And it will give you that by simply plugging it back in. Now, this is why it's so convenient to have this typed here. If I want to just put in, see, I already have it labeled as h of t, right? I have the exact same equation in Desmos. If you want to pause right now, pause the video and then get Desmos out, get caught up with me, I'll leave that right there. Okay, so what we're going to do now is we would just put in h of 1.020, and you can actually just copy this and paste it in there. You can see the maximum height is 7. And again, that is this point. It's important to remember that for later when you look at polynomials, because in polynomials, you have to use this feature. All right. Now, to solve for the ground, what's great about that is all we have to do there is go back to Desmos and type in the quadratic formula. So that is x equals minus b plus the square root. So square root, you're going to want to toggle the keyboard. B squared minus 4ac. And then you're going to highlight the entire thing and then divide by 2a. And that's going to give you your first answer. Look, if you look at the graph, it looks like, right? But it's the same thing, which is kind of cool, right? Equal to 0. And then you can copy this and then change that to a minus. And then you can see the other value, which is right there. Very, very handy. Okay. So that's the problem in a nutshell. And that's actually what you'll be doing for the rest of them. Oh, I almost forgot this one. When you have to set something equal to a number, like right here, the only thing that changes is I take this equation right here, and I would set it equal to 10, okay? And so when you set this equal to 10, what ends up happening is you do have to move it over, and you're just going to change your C value. So down here, it's the same thing. I put it out of order. So here I ask you when it's the ground first, then I ask you the maximum, just to keep your equation straight. The only thing that's hard about this problem is realizing that, the person is at the cliff is 20 feet. So, 20 meters. So if this is 20 meters right here, then the person themselves is another 2 meters. So you would actually add them up. And so the only sneaky thing about this problem is that the start height is 22 meters. All right, the Roman army problem is the same thing. It's back to having this first and that second. Now, the only thing in this problem that's interesting is what do you do with when is the boulder at half its maximum height? Well, first of all, you have to do the maximum. So you're going to find this answer. And then half its maximum height means divide this answer. You're going to divide whatever you get here. You're going to divide it by 2. And then you're going to plug that into right there. And then you're going to use the quadratic formula and solve again. So some students might say, well, why don't I just look at the graph? Well, as you can see, there's a lot going on. So having them both there is important. And the formulas, if you already have them typed in, can be much faster. In fact, you can use these formulas in Desmos right here for the rest of the assignment. So when you look at the back, you have a problem here where you're setting up the sum of 2 numbers is 30, and the product is as big as possible. So the product x times y is p. You're trying to maximize p. And then you're going to solve this for y and plug it in so that you get an equation that's in terms of one variable. Again, I wrote the equation out, well, x plus y equals 30 because the sum of 2 numbers is 30. then it says the product is as large as possible, so x times y is the product, and then I solve for y to solve the system. And you're going to be using this because it asks for the maximum. But then when it says equal to 33, you're going to be using the quadratic formula, right? So when it has an equal sign, you start thinking about x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Now, why don't you just, graph it or whatever? Because this is where it starts to get a little bit tricky about what it's saying. So you actually don't need the graph here. Maybe we get rid of it for these problems because it might throw you off. In this problem, A is -1 and B is 30 and then C is 0, okay? And so this is already here, so I already know the answer is 15. However, when I put it back in, right, if I want to put -b over 2a in, the question is, where do I put it back in? And the answer is both places, okay? So I need to put it here, right? But I also, that'll give me the product, but I also need to put it back in the y equation. You're going to need to put it in both, right? So that's why maybe the graph is misleading. To find the dimensions, right, I need to put it in here. When you do that in Desmos, if you don't use function notation, you just replace the x by the value. It was 15, as you can remember. Just get rid of the x. So the y value is 15, but the maximum product is going to be equal to a different number. And part of these problems on the back is keeping it all straight, right? You have to keep straight, like, what is happening. So you get that. Now, that is super important for the quadratic formula problem where we set it equal to 33. And so if I set this equal to 33 here, I'll just do it right below here. So if I put 33 here and I solve this, the reason this is so important to realize what's happening is many students, they put the wrong answer in those blanks, okay? So when I set this equal to this, I would move the 33 over, and now we can just go back into Desmos and make a little change. So I have -1, 30, and then C will be -33 because you do have to subtract it. I already have the quadratic formula in here, so you can see the two answers. So a lot of students will put those in, but they're not the answer. This is the X part of it, and this is the other X, right? If I want to find the Y, I got to put it back in this red thing. So you just have to be careful that you're not putting these two numbers blindly right here. It's one of the things I'm going to check immediately. There's actually two answers. One of them is 1.14, and that will match if I put that into here. That's going to match with the Y value of 28 because it wants the dimensions. So 28 point, and in this case, they're the same, again, because the coefficients are right here. So in this one, maybe it doesn't matter, but it's really going to matter in this one. And I will be definitely grading that. So that one's actually going to have two answers. There's going to be one there, and there's going to be one down at the bottom. So this one, the only difference is it's the same problem, but it says find two numbers where twice one number plus another, right? So there's a 2 on the Y. Now, when you're doing a problem where you're trying to maximize the area under a constraint, and this is one that some students have trouble with, so let's take a look at it a little bit closer. What I did was I drew this equation, which is y equals mx plus b, but it's backwards. So like this is y equals mx plus b, but it's actually, right, they put the b here, and then the mx is here. This is a common thing they do on standardized tests. So I started at 2, I went down 2 and over 5, making this constraint. The other two constraints are the x and y axis. So one of the constraints is the x axis, the other one is the y axis. And what this means is, sorry, the y axis and the x axis. And what this means is that the x axis, which is the length, is the input. Remember, we talked a lot about input and output. And once I decide upon that x value, so I'm going this way, let's say I decide to go here, it's going to then have to go up to the constraint. No matter where I go, that constraint is this blue line. So the x input is how long the box will be. And then the output, which is always this, it's limited by that line. The output is the height or the width, however you want to think about it. So I did area, right? I did area as length times height in this case. But if you want to use it as width, that's fine. That's a cursive L right there, not an E, because a normal L looks like a 1. So I use cursive L. And then the L is the X and the height is the line. So then that comes out to X, and then the line is Y equals 2 minus 2/5 X. And so once I have that, I have everything I need to find the area equation. So the area is going to come out to x, right? And then times the height, which is 2 minus 2/5 x. And you're going to want to distribute that. And then it becomes just a normal problem, right? It's going to be very similar to one above after this point. So the area will become a quadratic. Make sure you write it in order, right? So it'll be negative 2/5 x squared plus 2x. And then if I want to find the vertex, minus b over 2a. If I want to set it equal to 2, I'm going to put 2 there and use the quadratic. Then you have another one here just for fun to make sure you understand what's happening. One of the problems that actually I think makes the most sense is the problem over here that is talking about someone who is trying to sell an item. In this case, she's a farmer, so she's selling a pig that's worth 200 pounds. So if you were in like, if you were in like 6th or 7th grade math and they said, how much does a pig cost? And you just know it's a product, 200 times 140, that's going to give you the value now on day 1 or week 1. But then if the pig is gaining 5 pounds, we have another y equals mx plus b situation. And in this case, this is the m, as you can see, and then the b is here. Okay, then we have another situation where they have to price. Well, again, the price is dropping 2 cents per week. How much did you start with? $1.40. So that would be negative 0.02 plus $1.40 as the start. And now you might say, why is it negative, Mr. King? You gotta be careful of this word right here, right? It's dropping that much money. All right, and then you just multiply them together and you FOIL them, you plug numbers in, you find the domain and range. One thing that some students have trouble with is what is the domain? Well, the domain is, and I decided next year to actually put at the top that she bought this pig on January 1st, so that you would know that the domain was 0 to 52 weeks, because that's how many weeks are in a year. The range would be to plug 52 into the problem. Maximum amount, you're still going to use minus b over 2a. When is the pig worth $300? You're still going to use the quadratic formula. Down here, you have a similar one, right, where you have someone collecting aluminum cans. You can see I already updated this, right, where it says on January 1st. That way, yours does not, but this one does. So you would get an amount if they sold it on January 1st, but then 5 more per week, dropping 3 cents per week. You find the product, you plug stuff in, domain and range, then the maximum in the quadratic formula. In general, if I were to give you another hint, get Desmos open on your paper. Just every single problem uses the same 2 formulas. So if you have this open, it'll be very helpful, and you may use it on your assessment this time. I hope this was helpful, and I hope that you're able to learn why we're learning all this math, right? Remember, when you set something equal, you're finding x-intercepts, but they're t-intercepts or what have you. When you're finding the maximum, you're finding the vertex, but now it actually serves a real-world purpose.